Hello everyone, we are Onur Aydın, Taha Çakırca and Yusuf Güler. Our project title is Manufacturing Process Analysis of Bosch GWS 750 115 Angle Grinder. This project was prepared for a manufacturing process lecture. In this presentation, we will explain the product, its main components, materials, manufacturing processes, assembly quality control, safety, and conclusion. The product selected for this report is the Bosch GWS 750 115 angle grinder. An angle grinder is a portable electric hand tool. It is used for cutting, grinding, polishing, and surface finishing. It is commonly used in workshops, construction sites, metalworking, repair, and maintenance applications. We selected this product because it is not a simple product. It includes many mechanical and electrical parts. These include the plastic body, housing, aluminum, gearbox housing, steel gears, spindle, bearings, copper windings, switch, power cable, discard, and side handle. The aim of the report is to examine the product in terms of function, main components, materials, manufacturing processes, assembly, and quality control. A physical teardown was not performed. Instead, our analysis is based on standard angle grinder structure, product information, spare part references, and manufacturing process knowledge from the course. Product description and technical specifications. The Bosch GWS 750 115 is a corded electric angle grinder. It can be used for cutting, grinding, deburring, and surface finishing. The working principle is simple. When the user turns on the switch, electric current reaches the motor. The motor rotates the armature shaft. This rotation is transferred to the gear system. The gears change the direction of motion and transmit power to the output spindle. The cutting or grinding disc is connected to this spindle. During operation, the disc rotates at high speed and removes material from the workpiece. The main technical specifications are the rated input power is 750 watts. The no-load speed is 11,000 RPM. The disc diameter is 150 millimeters. The spindle thread is M14. The weight is about 1.8 kilograms. These specifications show that the product is compact but powerful. Since the disc rotates at high speed, the components must be strong, accurate, and safe. Technical, schematic, and component identification. In this part, we identified the main components of the angle grinder. The product includes external and internal components. External parts are visible during normal use. Internal parts transfer electrical power into rotating motion. We divided the product into 5 main groups. As you can see here. The first group is housing parts. These are the plastic body housing and gearbox housing. The second group is motor parts. These include the armature, stator, carbon brushes, and wiring. The third group is transmission parts. These include the pinion gear, level gear, bearings, and output spindle. The fourth group is safety parts. These include the discard and side handle. The fifth group is control parts. These include the switch and power cable. The exploded view schematic in the report shows the position of the motor, gearbox, gears, spindle, guard, handle, switch, cable, and housing parts. This components identification is important because the rest of the report explains the materials and manufacturing processes of these parts. Now, Taha will continue with the materials used in the angle grinder.
Thank you, Onur. In this part, I will explain the materials used at the Bosch Angel grinder. The Angel grinder used different materials for different functions. The main material groups are polymers, aluminum alloy, steel, copper, carbon, and abrasive materials. Each material is selected according to its function. Some parts need strength, some parts need electrical insulation, some parts need wear resistance, and some parts need good heat transfer. Polymers. Polymers are used in the body housing, switch casing, cable insulation, and side handle. The plastic body housing is usually made from ABS or reinforced polymer. These materials are light, impact resistant, and electrically insulating. This is important because the user holds the tool during operation. The housing must protect the user from electrical parts. It must also protect the internal motor from dust and impact. The side handle may include rubber coating. This improves grip and helps reduce vibration. Polymers are also suitable for injection molding. This is useful because the housing has a complex shape with grip areas, ventilation openings, screw holes, and internal supports. Aluminum alloy. Aluminum alloy is used for the gearbox housing. The gearbox housing supports the gear system and the spindle. It is located near the front of the tool. This area can become hot during operation. Aluminum is selected because it is lighter than steel. It also transfers heat well. This helps remove heat from the gearbox area. Another advantage is that aluminum is suitable for die casting. Die casting allows the production of complex shapes. This makes it a suitable process for the gearbox housing. Steel. Steel is used in many important parts of the angel grinder. These parts include the gears, shaft, spindle, bearings, screw, and disc guard. Steel is selected because it has high strength and good wear resistance. The gear and spindle work under rotation and load. Therefore, they must be strong and accurate. The gears are usually heat treated to improve hardness and service life. The bearings are made from bearing steel because they must reduce friction and support high-speed rotation. The disc guard is made from stamped steel sheet. This part protects the user from sparks and possible broken disc pieces. For this reason, tautness and impact resistance are important. Copper and electrical materials. Copper is used in the motor winding, internal wiring, and power cable. Copper is selected because it conducts electricity very well. This allows electrical current to pass efficiently through the motor and cable. The copper wires are covered with insulation. This prevents short circuits and improves electrical safety. Electrical steel laminations are also used in the armature and stator cores. These laminations help the motor work efficiently. Carbon and abrasive materials. Carbon brushes are made from carbon or graphite. They transfer current to the rotating armature. Carbon is suitable because it conducts electricity and can slice against the commutator. The cutting or grinding disc is made from abrasive grains bonded together. The abrasive material is harder than the workpiece. This allows the disc to cut or grind metal, stone, or concrete. To conclude this section, material selection is based on function. Polymers are used for insulation and comfort. Aluminum is used for light support and heat transfer. Steel is used for strength and wear resistance. Copper is used for electrical conductivity, and carbon and abrasive materials are used for current transfer and cutting performance. Now, Yusuf will explain the manufacturing process and the final stage of the product.
Thank you, Taha. In this part, I will explain the manufacturing processes used for the Bosch angle grinder. The product is made by using several processes. These include injection molding, die casting, machining, gear cutting, heat treatment, sheet metal forming, wire driving, motor winding, and assembly. Each process is selected according to material and function of the component. Injection molding is used for plastic parts such as the body housing, switch casing, and side handle. In this process, plastic pellets are heat until they melt. The molten plastic is injected into mold under pressure. After cooling, the part is removed from the mold. This process is suitable because the housing has a complex shape. It also provides good repeatability for mass production. The gearbox housing is made from aluminum alloy by die casting. In the process, molten aluminum is forced into a steel mold. The metal fills the cavity and solidifies into the required shape. After solidification, the part is removed and trimmed. Die casting is suitable because the gearbox housing has a complex shape. After casting, holes and surfaces are machined for better accuracy. The motor shaft and output spindle are made from steel. These parts need accurate dimensions because they rotate at high speed. Turning is used to create cylindrical surfaces. Trending is used from the spindle thread. Grinding may be used to improve surface finish and accuracy. The pinion gear and bevel gear are made by gear cutting methods such as hobbing, milling, or shaping. After gear cutting, heat treatment is used to increase hardness and wear resistance. This is important because the gears work under repeated contact. If the gear teeth are not accurate, the tool may create noise, vibration, and power loss. The disc guard is made from steel sheet by stamping and forming. This process is suitable because the guard has a covered sheet metal shape. Copper wire produced by wire driving. Then it is coated with insulation and wound around the armature and stator cores. This creates the motor windings. Bearings are made from bearing steels. They are shaped, heat-treated, ground, and polished. This gives low friction and smooth rotation. Squeeze are produced by cold heading and thread rolling. These processes are efficient for producing small fasteners in large quantities. The power cable is made from copper conductors and polymer insulation. The insulation is added by extrusion coating. After components are produced, they are assembled into the final angel grinder. First, motor subassembly is prepared. The armature, stator, brusher, bearings, and wiring are insulated. Second, the gearbox subassembly is prepared. The gears, bearings, spindle, and lubrication are placed inside the aluminum gearbox housing. Third, the motor and electrical parts are placed inside the plastic body housing. The switch and power cable are connected. The housing is then closed with screws. Finally, the safety parts are attached. These include the disc guard and side handle. The general assembly sequences is raw materials, components manufacturing, motor subassembly, gearbox subassembly, electric assembly, housing assembly, safety parts installation, final testing, and packing. Quality control is important because the tool works at high rotational speed. Dimensional inception is used for the shaft, spindle, gears, bearings, and gearbox housing. These parts must fit correctly. If they are not accurate, the tool may vibrate or wear quickly. Electrical testing is applied to the motor, switch, internal wiring, and power cable. This checks current flow and insulation safety. After final assembly, the product is tested without load. This checks speed, motor function, vibration, and noise. Safety inception checks the discard, housing, switch, cable, and side handle. These parts must protect the user during operation. Safety is very important for an angle grinder because it is used for cutting and grinding at high speed. The discard protects the user from sparks and possible broken this piece. The side handle improves control during operation. The plastic housing and cable insulation protect the user from electric shock. Manufacturing safety is also important. Die casting involves molten metal. Machining involves sharp tools and rotating parts. Stamping uses high force presses. For this reason, workers need protective equipment and machine guard. There are also environmental considerations. Metal scrap from machining, stamping, and casting can be collected and recycled. Aluminum and steel are especially suitable for recycling. Efficient machines and process planning can also reduce energy use and material waste. To conclude, the Bosch angle grinder is a good product for manufacturing analysis. These include different materials such as polymers, aluminum alloy, steel, copper, carbon, and abrasive composite. It also uses several manufacturing processes, plastic parts, injection molded. The aluminum gearbox housing is die casting. Steel parts are machined, formed, and heat treated. Copper wire is drawn and wound for the motor. After production, all components are assembled and tested. The product shows how material selection, production process, assembly, quality control, and safety are connected in one engineering product. Thank you for listening to our presentation.
Yusuf'u 1.25 yazıyor.